Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
All right, welcome to this explainer. Today we're diving straight into the absolute core of project management, uncovering the foundational concepts behind how major initiatives are actually accomplished. Whether you're leading a team for the very first time, or maybe you've been working on massive corporate initiatives for years, the fundamental physics of getting things done, they remain exactly the same.
Just think about it for a second. How does something as incredibly complex as constructing a massive power plant actually get done? Big achievements simply don't happen by accident. Building that plant isn't just about having the right engineers or the right materials lying around. It's about organizing literally thousands of moving parts into a singular, successful outcome. It is a deliberate, meticulously orchestrated effort. So, here's our roadmap for today. We'll start by defining what a project actually is, then demystify the management side of things, explore the tricky balance of scope, time, and cost, outline the project manager's specific role, and finally, we'll cover how to avoid the most common mistakes.
Okay, let's jump right into Section 1. What is a project? Let's define the basics.
A project is fundamentally completely different from your everyday operations. While your routine work is repetitive, the stuff that sustains the business day to day, projects are unique efforts that step entirely outside that status quo. We're talking about constructing that power plant, installing a brand new turbine, or maybe implementing a new computerized maintenance management system. You are literally leaving the routine behind to build something entirely new. And here's a crucial point. Projects are never indefinite. They have a hard start and a hard finish. By definition, a project is a temporary effort undertaken to create a unique product, service, facility, or result. Basically, you do the work, you achieve that specific outcome, and then the project is officially over.
It really boils down to three core characteristics. It's temporary, it's unique, and it has a defined objective. Honestly, whether you're building a massive suspension bridge or writing a new piece of software, if it doesn't have a specific end date, a totally unique outcome, and a clear goal, well, it's just not a project.
And hey, scale doesn't change the physics of a project at all. From simply installing some new equipment on a factory floor, to a full plant modification, implementing SAP, or even establishing a massive new physical warehouse, the exact same rules apply. They're all temporary, they're all unique, and they are strictly defined by their ultimate objective.
Moving right along to Section 2, Demystifying Project Management. Let's look at how it actually works.
Now, I know this sounds a bit like corporate jargon, but project management is really just applying knowledge, skills, tools, and techniques to meet specific requirements. That's it. It's the rigorous, step-by-step engine of planning, executing, and closing that actively drives the effort forward. It's what turns an abstract idea in your head into a finished working product.
Think of the project manager as someone juggling a massive, multi-dimensional puzzle. You aren't just making a schedule, you're balancing the entire scope of work, the budget, the physical resources, the quality of the output, unforeseen risks, procurement, and, maybe hardest of all, the complex communication and expectations of every single stakeholder involved.
Which leads us perfectly into Section 3, Scope, Time, and Cost, the ultimate balancing act.
This is probably the most famous concept in the entire industry, the project management triangle. You've got scope, time, and cost sitting at the three corners, with quality resting right there in the middle. And the tension here is absolute. If you pull on one corner, the others must inevitably adjust, or your quality is absolutely going to suffer. Let's make this real. Say you're building that power plant, and suddenly the client asks you to add an entirely new facility wing. That is a massive increase in scope. Well, you're inevitably going to require more time, more resources, or a bigger budget to pull that off. Adding scope without adjusting your timeline or your money will instantly degrade the quality of the build. It's what we call scope creep, and honestly, it obeys the laws of physics every single time.
All right, Section 4, the project manager's role, coordinating success.
The absolute biggest distinction you need to make here is between leadership and technical execution. The project manager is responsible for coordinating the project, not doing every technical activity personally. You are the conductor of the orchestra. Your job isn't to actually pour the concrete or weld the pipes, it's to ensure the person pouring the concrete has exactly what they need, exactly when they need it, so they can succeed. From defining those initial day one objectives to formally closing the whole thing out, the manager's fingerprints are on every single phase. We're talking developing plans, managing resources, controlling the schedule and costs. They're actively mitigating risks before they blow up into disasters, coordinating stakeholders, reporting progress, ensuring quality, and managing those inevitable, sometimes frustrating changes that always pop up along the way.
Let's ground this in another real-world scenario. Say you're tasked with installing a new 10-megawatt generator. As the manager, you coordinate the exact chronological path. Step 1, feasibility study and engineering. Step 2, procurement and civil work. Then Step 3, equipment delivery and installation, followed by testing and commissioning, until finally, Step 5, the official handover. You are the singular thread tying all those disparate phases together into one cohesive timeline.
Finally, Section 5, Avoiding Common Mistakes, the traps to avoid.
Now these right here, these are absolute project killers. Starting without a clear objective is quite literally like driving blindfolded. Throw in poor scope definition, an unrealistic schedule, inadequate resources, or simply ignoring risks, and you've basically set the team up for failure before you've even broken ground. And don't even get me started on poor communication or weak documentation. If you allow uncontrolled changes to happen, they will quickly derail even the most perfectly engineered plans.
Our source material sums this up beautifully. Project management is not simply making a schedule. It is the complete process of converting an objective into a successful result. It's a holistic, transformative discipline. It's the art and science of turning a conceptual goal into a tangible, working reality. So as you look toward your next big initiative, you've got to ask yourself, are you just making a schedule, or are you architecting success? How are you going to coordinate the scope, the timeline, and all those stakeholders to actually turn your blueprint into reality? It's a lot to think about, right? Thanks so much for joining me on this explainer, and good luck with your next project.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome to this explainer. Have you ever watched a massive project just spiral completely out of control? Bleeding time, bleeding money? Well, today, we're going to demystify project management. We are breaking down the 5 essential stages every project manager absolutely must know to turn chaotic ideas into successful realities. Whether you're building a skyscraper or rolling out a new piece of software, this framework, it's the backbone of getting things done efficiently. Okay, here is our roadmap for today. We'll start with the high-level project lifecycle, dig right into initiation and planning, move through execution and monitoring, wrap it up with project closure, and then tie the whole shebang together with a real-world example. Let's jump right into Section 1, the project lifecycle. Think of the project lifecycle as your ultimate organizational savior. Literally, it is a structured sequence of 5 stages that takes these massive, intimidating undertakings and breaks them down into totally manageable steps. Every single project, no matter the industry, passes through these exact phases: initiation, planning, execution, monitoring and controlling, and closing. By mastering these 5 steps, you don't just bring ideas to life, you do it predictably, on time, and on budget. Moving right along to Section 2, initiation and planning.
Everything starts with initiation. This is that critical moment where a project idea is rigorously evaluated before any real money is spent or any real work actually begins. You're basically asking the big question here: is this project actually worth doing? Trust me, skipping this phase is the #1 reason projects end up hemorrhaging cash down the line.
During this evaluation, you've got to quickly check off a few vital activities. First up, pinpoint the exact problem you are solving and define crystal clear objectives. You absolutely must identify your stakeholders too, the folks with a vested interest in the outcome. Then, you're conducting feasibility studies, estimating initial costs, and spotting any major high-level risks. And finally, you officially lock the whole thing in by preparing a project charter. That is your official green light.
Once officially initiated, we step into the planning stage. This dictates exactly how we are going to pull this massive undertaking off. If initiation was the what and the why, well, planning is entirely focused on the how.
And wow, the sheer volume of preparation required here is massive. You're building a completely robust foundation with 9 specific plans before a single physical action is taken. You need a scope plan and a work breakdown structure, which, by the way, just means chopping the monster project into bite-sized, actionable tasks. You also need a solid schedule, a resource plan to know exactly who's doing what, a detailed cost estimate, and a quality plan. Plus, you're building a risk register to anticipate problems, a communications plan to keep everyone in the loop, and a procurement plan for everything you need to buy. It's a lot, I know, but this is exactly how you prevent absolute chaos later on. All right, Section 3, Execution and Monitoring. Execution. This is the exciting part where all those theoretical plans finally become a physical reality. This is where the budget actually gets spent, your team rolls up their sleeves, and the real magic happens. The actual tangible work is performed here. We're rapidly moving through procurement of materials into engineering, construction, and installation. But hey, it doesn't stop with just building the thing. Execution carries you all the way through rigorous testing and even training your end users. It's a crucial step that a lot of novices skip, but it ensures people actually know how to use what you've just built. Now, at the exact same time, you enter the monitoring and controlling stage. And this brilliantly comes down to one core concept: expectation versus reality. You've got to constantly pit the reality of your actual progress against the expectations of your planned progress. While your team executes, you're the ultimate supervisor, constantly measuring reality against that baseline plan. To keep the whole project from derailing, a vigilant project manager tracks 5 specific metrics. You are tracking actual costs against the budget, the real timeline against the schedule, and making sure the quality is up to standard. You're also actively monitoring those risks you identified back in the planning stage, ensuring any necessary changes are handled immediately and appropriately so they just don't snowball. Up next, Section 4, Project Closure. Closing isn't just packing up your desk, high-fiving the team, and walking away. Nope. It is a highly structured, formal completion of the project. A project just isn't truly finished until it goes through this rigorous process. This critical wrap-up requires ticking off a few final, very important boxes. You're handing over deliverables to the client, but only after a final inspection, testing, and acceptance. You're finalizing all those payments, officially closing out contracts, and releasing your team resources so they can jump onto other initiatives. But the absolute most important part? Gathering lessons learned. This right here is the secret sauce. It allows your organization to avoid the exact same mistakes on future projects, and honestly, it's what separates good organizations from truly great ones. Let's bring this to life. Section 5, a real-world workshop example. Watch how flawlessly this framework maps to reality. First, you initiate by identifying the business need for, say, a new maintenance workshop space. Then, you meticulously plan its blueprint design, lock in that budget, and create the work breakdown structure. Third, you execute by physically constructing the building and installing the equipment. Fourth, you concurrently monitor your costs and building quality during that construction. And finally, you close by completing the commissioning process and actually handing over the keys to the operations team. So, the crucial point to take away from this framework is that it is your absolute, undeniable roadmap to success. By respecting these 5 stages, you completely remove the guesswork from project management. You replace it with predictable, repeatable success. Now that you are armed with this clear, 5-step explainer roadmap, how are you going to apply it? What chaotic idea will you structure and bring to life next? Thank you for joining this explainer. Now get out there and start planning.
The project lifecycle has 4 key stages: initiation, planning, execution, and closing.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome to this explainer. Today, we're going to dive right into the absolute foundation of successful project management, building a completely bulletproof project blueprint. We're going to break down exactly how you start a project the right way by mastering the project charter. Look, we've all been there, right? You get handed this massive, complex project, you look around at your team, and you realize nobody can clearly answer one simple critical question. Why are we actually doing this? It's incredibly frustrating. You're ready to get to work, but without clear direction, you're literally just spinning your wheels. Honestly, this is the core problem every single team faces when kicking off a new initiative. Because if you don't know the why, well, you can't possibly figure out the how. And that is exactly where our hero comes in, the project charter. By definition, it's a formal document that authorizes the project and gives the project manager authority to use organizational resources. Think of it as your ultimate anchor. It stabilizes the team, officially greenlights the initiative, and most importantly for you as a project manager, it grants you the actual formal authority to spend money, allocate time, and assign people to get the job done. So here's our roadmap for today's explainer. First, what is a project charter? Second, anatomy of a charter. Third, setting smart objectives. Fourth, a real-world charter example. And fifth, why the charter matters. All right, let's jump into Section 1. What is a project charter? The formal starting point. The absolutely crucial takeaway here is that the project charter is your project's formal starting point. Think about it like building a house. I mean, you would never start pouring a concrete foundation or framing up walls without an approved architectural blueprint, right? Well, in the business world, you simply cannot start a project without this charter formally establishing your baseline. It's that undeniable line in the sand where a totally abstract idea transforms into an officially sanctioned project. Moving on to Section 2, Anatomy of a Charter, the 13 major contents. What's really interesting here is how this maps out the DNA of your project. A solid charter generally includes 13 major contents, perfectly balancing high-level strategy with logistical boundaries. On the strategic side, you absolutely must define things like the business need, the scope, and your key stakeholders. But, a strategy without boundaries is really just a wish. So logistically, you lock in the high-level schedule, budget estimates, and constraints. This balance ensures your project is structurally sound from day one. Now for Section 3, setting smart objectives. Clear and measurable goals. Okay, so the vital point here is that your project objectives must be clear and measurable. A vague goal? That's a project killer. The absolute best way to ensure clarity is the SMART framework. Let's unpack this quickly. S stands for specific, no ambiguity about what you're doing. M is for measurable. You need clear metrics to know if you actually succeeded. A is for achievable. It's got to be rooted in reality. R is for relevant, it must solve that business need we just talked about, and T is for time-bound, because let's face it, a goal without a deadline will drift forever. Actively using these 5 specific letters actively prevents your project goals from wandering off track. Let's look at Section 4, a real-world charter example to really ground this theory. Picture this tangible, industrial initiative. Your project is the installation of a new 5-megawatt emergency generator. It's highly specific, it's a very physical project. This is exactly what a properly scoped initiative looks like right out of the gate. But the real question is, how do we turn this basic title into a rock-solid, smart objective? Take a look at this. This brilliantly illustrates the power of a well-written objective. Install, test, commission, and hand over a 5-megawatt emergency generator within 12 months while meeting approved safety, quality, cost, and technical requirements. Notice how this one single powerful sentence hits the entire SMART criteria. It's incredibly specific about the actions. Install, test, commission, handover. It's measurable with a 5-megawatt output and hitting those approved cost and technical targets. It's achievable and relevant to the safety standards of the facility. And boom, it's perfectly time-bound with the phrase within 12 months. When your charter has an objective this clear, your team knows exactly what winning looks like. Which brings us to Section 5, why the charter matters, securing your project's success. Let's directly contrast these two realities. Without a charter, project authority is a complete blur. Objectives inevitably change on a whim. Stakeholders have wildly different expectations, and resources, they simply aren't available when you need them. It's a total recipe for disaster. But with a charter, you possess clear, documented authority. You have stable, smart goals. Stakeholders are totally aligned, and your resources are fully secured. It's literally the difference between navigating a ship with a broken compass versus having a state-of-the-art GPS. Now, before we wrap things up, I want to leave you with a massive professional tip derived straight from the source material. Listen closely to this. The project charter must be approved before detailed project planning begins. I really want to put heavy emphasis on this. Do not waste a single minute of your team's time building out massive Gantt charts, complex work breakdown structures, or micro-schedules until this charter is officially signed off. If you start detailed planning without an approved charter, you're building a highly detailed schedule for a project that technically doesn't exist yet, and that is a massive waste of organizational resources. So, as we conclude this explainer, I want to challenge you to reflect on your own work for a second. Look at the initiatives you're managing right now. Is your next big project built on a solid charter with clear authority and smart objectives? Or is it already drifting without an anchor? Take these insights, deploy this formal starting point, and lock in your project's success from day one. Thanks for joining me on this explainer, and I'll catch you next time as we continue breaking down the strategies that make you better at what you do.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Today, we're diving into a topic that can literally make or break any initiative, and that's project scope management. Now, for this explainer, we're going to cover exactly what's included in this source material, and we are going to exclude absolutely everything else. See what I did there? Just a little scope management joke to kick things off. But seriously, let's jump right in and explore how to definitively prevent project scope creep.
You know, every project, whether it's massive or completely microscopic, essentially boils down to two really fundamental questions. What is included and what is excluded?
It all comes down to this core duality. On one side, you have what the project will actually deliver, and on the other, what it's going to exclude. Defining that rigid, uncompromising boundary between these two sides, well, that's the entire foundation of project scope. If you don't know the precise difference between these two for your specific initiative, you're basically flying blind. Okay, here is our agenda for today. 1. Defining project scope. 2. The management process. 3. Crafting the scope statement. 4. Beware of scope creep. And 5. Mastering scope control.
Section 1. Defining project scope.
According to our source material, project scope defines exactly what the project will and will not deliver. So the absolutely crucial point here is that second part of the definition. It is just as vital, maybe even more vital, to know what a project will not deliver as what it will. When everyone agrees on what isn't happening, you're protecting your time, your budget, and honestly, your sanity. Section 2. The management process. All right, here is the 6-step methodology mapped out for us. First, plan scope management. Then, collect requirements. 3. Define scope. 4. Create the work breakdown structure, or WBS. 5. Validate scope. And 6. Control scope. This is your proven roadmap. You plan your approach, you figure out what people actually need, you draw that boundary, break the work down into manageable pieces, ensure it's correct, and then you fiercely control it.
Let's zoom in on collecting requirements for a second. Capturing stakeholder expectations means you really have to look at specific, quantifiable factors. We have to map out things like capacity, performance, safety, quality, reliability, and of course delivery time to truly understand the project shape. You've got to capture all of these to give your scope some real structural integrity.
Section 3. Crafting the scope statement.
A really robust scope statement is going to contain these 5 key components: deliverables, boundaries, acceptance criteria, exclusions, and constraints. Putting these down on paper is a total game changer because it turns vague expectations into a binding, agreed-upon reality. Notice how explicitly defining things like exclusions and boundaries solidifies your project's perimeter right from day one.
Section 4. Beware of scope creep.
Okay, here's the villain of our explainer. Scope creep occurs when additional work is added without proper evaluation and approval. I really want to stress that key phrase right there, without proper evaluation and approval. I mean, projects change, right? That's completely natural. Actually, scratch that. It's inevitable. But when those additions completely bypass the evaluation process, you get chaos. Let me show you how innocently this kind of thing starts out. Here's a great example straight from the source. The original project request is super simple. Install a new pump. That's it. Simple, straightforward, and very clearly bounded.
But then, you know how it goes. The later requests start rolling in. Hey, while you're at it, can you install some additional pipelines? Oh, and we're definitely going to need to upgrade the electrical panels for that. Actually, could you just modify the entire control system? And you know what? Let's just construct a brand new building to house the whole shebang. Look at the sheer absurdity of this. A simple pump installation has literally spiraled into constructing a brand new building.
If these changes are just added without proper approval, scope creep occurs. Your project has officially fallen victim to it. Those extra pipelines and that shiny new building will absolutely destroy your budget and your timeline if they're just tacked on without proper authorization.
Section 5. Mastering Scope Control. So, how do we fight back? Every single proposed change must be rigorously evaluated against the 6 specific factors in this definitive checklist. When someone comes to you and asks for a new building instead of a pump, you run it right through this exact criteria: cost, time, resources, risk, quality, and technical impact.
You must evaluate every proposed change. Taking this step is exactly how you neutralize those unapproved additions. It basically removes all the emotion from the request and forces everyone involved to look at the tangible, cold hard realities of adding more work to the plate.
Our source material leaves us with this incredibly empowering takeaway. A clearly defined scope is one of the strongest protections against project failure. It gives you the power to confidently say no, and it provides the exact framework you need to safely say yes. Knowing all of this now, how will you rigorously define and protect the boundaries of your next project?
What exactly is scope management? It defines and controls all project work, ensuring you deliver exactly what was agreed, no more and no less. Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome to the explainer. So if you have ever stared at a massive new project assignment and felt your heart rate instantly double, well, you're in the right place, because this is the ultimate remedy for that. Today, we're completely breaking down the work breakdown structure, or WBS. Seriously, how do you actually tackle a massive project without a single tiny detail slipping through the cracks? Industry data actually shows that poorly defined scope is the #1 killer of project budgets. I mean, we all know that terrible feeling of staring at a blank whiteboard, right? A brand new project lands on your desk, the deadline is absolutely terrifying, the budget feels way too tight, and the sheer volume of what needs to get done is just swirling around in your head. It is incredibly anxiety-inducing. But what if you had a blueprint to totally neutralize that chaos and give yourself absolute clarity? Okay, let's dive right into this. Our roadmap for today covers 5 key deliverables. We're going to demystify the WBS, talk about why it actually matters, look at WBS in action with a real example, cover the golden 100% rule, and finally, master the work package. And hey, fun fact for you, this very agenda is actually a real-time WBS itself. We've just broken this whole explainer down into 5 completely manageable chunks. Let's get going.
All right, part 1. Let's start by demystifying the WBS. By definition, a work breakdown structure is a hierarchical decomposition of the total project scope into smaller, manageable components. Okay, yes, I know that sounds incredibly formal, but honestly, it's really just the highly technical way of saying we are going to take a massive, unmovable boulder and chip it down into a pile of easy-to-carry pebbles. And this logically illustrates exactly how that top-down flow works. You start right at the top, at the macro level, with your overall project. Then you take a step down. You divide that giant project into major deliverables. Next, you break those deliverables down even further into what we call work packages. And then finally, at the very bottom, you have your micro-level activities. The work literally just gets smaller, tighter, and crystal clear at every single stage. So why go through all this trouble to create this hierarchy? That brings us to section 2, why WBS matters. Think about the very last time you had to deal with a blown budget or a horribly missed deadline. It's the absolute worst, right? Well, a WBS is designed specifically to prevent those exact nightmares. Because you've sliced the project down into bite-sized pieces, your scheduling suddenly becomes incredibly precise. Cost estimation goes from being a wild shot-in-the-dark guess to a highly accurate calculation. And it's the exact same for resource planning. You know exactly what tools and materials you're going to need for every specific tiny chunk. Plus, it gives you crystal clear responsibility assignment, which completely eliminates that classic, "Oh, I thought you were doing that" conversation. It also makes progress measurement super easy, because you can literally just check off discrete tasks as you complete them. And finally, risk identification. I mean, it is just so much easier to spot a potential hazard in a small, isolated task than it is when you're looking at a massive project from 10,000 feet up. Let's move on and actually see how this builds out in the real world. Section 3, WBS in action.
Imagine our massive overarching level 1 project is the construction of a brand new maintenance workshop. Now, if you just turn to your team and say, hey, go build it, that's incredibly vague and totally overwhelming. So instead, we divide it into level 2 project phases. We've got engineering, procurement, civil construction, equipment installation, electrical installation, testing, commissioning, and finally, handover. Suddenly, build a workshop isn't just one terrifyingly giant task anymore. It's 8 distinct logical phases. And the absolute beauty of this framework is that we don't stop there. Each of those level 2 sections can, and definitely should, be divided even further down into level 3, level 4, and so on, until the tasks are actually small enough to hand off to an individual person. Which brings us to arguably the most important rule of the entire framework. Section 4, the Golden 100% Rule. Now, what's really interesting about this rule is that it's the absolute backbone of everything we're doing here. Your work breakdown structure must represent exactly 100% of the work required for the project. Literally no more and absolutely no less. It has to encapsulate the entirety of the project. If you sum up all the work at the lowest levels, it has to roll up perfectly to exactly 100% of your project scope. To put it as bluntly as possible, it must include all work necessary to complete the project. That means if a task or an activity or a deliverable is not formally listed in your WBS, then it simply does not exist in the project. It's totally out of scope. Following this 100% rule is exactly how you guarantee that absolutely nothing falls through the cracks. And honestly, just as importantly, it's what stops your team from wasting their time on tasks that aren't actually driving toward the project goals. All right, let's zoom all the way in for our final section, Section 5, Mastering the Work Package. If you remember from our earlier steps, a work package is the absolute lowest level of that hierarchical decomposition. But how do you actually know when you've broken a task down enough? Well, a true work package is a manageable chunk of work that hits 5 very specific criteria. First, it has to be something you can assign to a specific person or team. Second, the costs and resources for it must be able to be estimated. Third, it has to be strictly scheduled with a clear start and end date. Fourth, it needs to be easily monitored for progress. And fifth, it has to be controlled. Once your project chunks hit those 5 exact criteria, you finally have the practical tools you need to stop just planning and start actually executing. So the crucial point here, the big takeaway to remember, is that a work breakdown structure converts a massive, complex project into totally manageable pieces. I mean, that is the entire narrative arc of everything we've looked at today. It takes the overwhelming and makes it actionable. You're building a visual, structural roadmap that gives you complete control over your schedule, your costs, your resources, and your risks, all while making absolutely sure that 100% of your project scope is accounted for. Which really leaves us with just one final thought. Now that you have the blueprint, now that you actually understand how to break down total scope into deliverables, and then work packages, and finally down to individual activities, how are you going to structure your next massive project? The next time a truly monumental task lands on your desk, seriously, go grab a whiteboard, start right at level 1, and let this hierarchy do all the heavy lifting for you. Thanks so much for joining me to explore this incredible framework today.
A work breakdown structure, or WBS, breaks a project into manageable work packages. For example, a building project breaks down into design, construction, and final testing. Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome back to The Explainer. I am absolutely thrilled to have you here today because we're going to unpack something that is literally the ultimate blueprint for any successful project: project scheduling. We're going to see exactly how professional project managers actually plan activities. Whether you're building a massive skyscraper, rolling out a new software application, or organizing a huge corporate event, success doesn't just, happen by accident. It requires a meticulously crafted execution plan. So today, we are pulling back the curtain on how the pros construct these plans from the ground up, turning raw ambition into a real, tangible timeline.
Since project management is all about structure, here is our sequence of what we'll cover today before we begin the actual work. First, the core of project scheduling. Second, the 7-step scheduling process. Third, defining activities with precision. Fourth, understanding task dependencies. And finally, number 5, the baseline, your project anchor.
Okay, let's dive into this. Section 1, the core of project scheduling, the absolute heartbeat of your project. I'm sure we have all been a part of a completely chaotic project at some point, right? The kind where everyone is working incredibly hard,
But nobody quite knows what the big picture looks like. Deadlines start slipping, people step on each other's toes, and stress levels just go through the roof. That chaos is exactly what happens when you don't have a solid foundation. So I want to pose this directly to you. What exactly is project scheduling? Now, it's super tempting to think of it as just a fancy to-do list. Amateurs make this mistake all the time. They jot down a dozen things to do, maybe throw some dates next to them, and call it a day. But a professional, time-based plan is vastly different. It's a dynamic, interconnected model of your project. It doesn't just list what needs to happen, it dictates the exact rhythm and flow of how the work will actually be executed in reality.
To actually qualify as a professional schedule, it has to confidently answer these 5 critical questions. Number 1, what work will be performed? Number 2, when will it start? Number 3, when will it finish? Number 4, who will perform it? And number 5, what activities depend on each other? Listen, if your plan leaves even one of these questions unanswered, you are leaving the door wide open for confusion and delay. Every single one of these elements must be locked down to create a transparent, actionable schedule that your whole team can rely on.
Moving right along to Section 2, the 7-step scheduling process, from start to finish.
Now that we know exactly what our schedule needs to accomplish, how do we actually build it? Well, we follow a highly structured chronological life cycle. Here is the 7-step scheduling process. And what's really interesting here is how these steps naturally group together. The first 5, identify activities, sequence activities, estimate durations, assign resources, and develop schedule, represent your planning phase. This is where you're doing the heavy lifting to build the model. The final 2 steps, establish baseline and monitor actual progress, represent the monitoring phase. You do all that hard work up front in steps 1 through 5 so that you have a powerful tool to measure and enforce your success in steps 6 and 7.
Which brings us to Section 3. We're zooming in on the very first step here, defining activities with precision and avoiding vague deliverables.
Getting this step wrong literally derails your entire schedule before it even begins. You have to define your activities with absolute precision. If you let vague deliverables sneak in, you instantly lose the ability to accurately estimate time, assign the right people, or track progress. Ambiguity is the enemy of a successful project. And this brilliantly illustrates exactly what I mean. Take a look at the direction to simply install equipment. Sounds like a straightforward task, right? But how long does that take? Who is doing it? What does it actually involve? It's just way too vague. Now compare that to breaking that one vague idea down into a highly specific, measurable 8-step process. Prepare foundation, receive equipment, inspect equipment, position equipment, install equipment, connect piping, connect electrical system, and test equipment. Boom. By defining the activities this precisely, we suddenly have total clarity. We know exactly what needs to happen at every single stage.
All right, on to Section 4, understanding task dependencies and how everything connects.
Okay, so once we have these specific, hyper-detailed activities laid out, they're still just isolated puzzle pieces. We have to link them together in a logical sequence. We need to define the rules of how these tasks interact, and in project management, these rules are called dependencies. Understanding how this all connects is what transforms a simple list into a living, breathing schedule. The most common dependency you'll use is finish to start. It's exactly what it sounds like. Activity A must finish before activity B starts. Think back to our last example. You must completely prepare the foundation before you can position the equipment. One task entirely unlocks the next. It's a linear progression and it forms the backbone of almost every single project timeline.
Let's move to and see how this builds with the start-to-start relationship. Here, activity B can start after activity A starts. They don't necessarily have to finish at the exact same time, but their kickoffs are linked. This is a concurrent relationship where a second activity runs in parallel with the first. So, for example, once you start writing a new software code, your testing team can start writing the quality assurance protocols for that specific code. You overlap the work to save time.
The final dependency we'll cover is finish to finish. In this scenario, activity B must finish when activity A finishes. The two activities are tied together at their very end point. Imagine you're catering a massive dinner party. You want the task of cooking the main course and the task of preparing the side dishes to finish at the exact same time, so everything is served hot. The start times might vary wildly, but the finish times are strictly synchronized.
Finally, Section 5, the baseline, your project's anchor for measuring success.
We've built this incredibly detailed, logically sequenced timeline. But what happens on day 1 when the project actually kicks off? Reality hits. Things change. So the crucial point is the approved schedule becomes the baseline, and actual performance is compared against it.
When you finalize that perfect schedule, you essentially take a snapshot of it. That snapshot is your baseline. Without this anchor, you have absolutely no way to know if your project is genuinely on track. When task durations run long or start dates inevitably slip, you just compare reality to your baseline to immediately see the impact on your final delivery date.
Ultimately, a professional schedule converts project scope into a time-based execution plan. I absolutely love this quote. It perfectly summarizes everything we've explored today. It takes the abstract scope, those grand ideas of what you want to achieve, and grounds it all in the hard reality of time. This is exactly why scheduling is far more than a simple to-do list. It is your ultimate, indisputable blueprint for execution.
We've covered a lot of ground today, going from moving past vague lists all the way to establishing strict baselines and understanding complex dependencies. So I want to leave you with a question to chew on as you look at your own work. Now that you have the blueprint to measure actual performance against, what hidden project dependencies are currently delaying your most critical goals? Take a look at the projects sitting on your desk right now, apply these specific concepts, find those hidden bottlenecks, and take control of your timeline. Thank you so much for joining me for this explainer, and I can't wait to explore our next topic with you.
Project scheduling is the process of planning when each project task will start and finish. It helps teams sequence activities, manage time, and complete the project on schedule.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Let me ask you something right off the bat. How exactly are you managing your complex projects without completely losing your mind? If you've ever been the one steering a massive undertaking, well, you know the exact feeling I'm talking about. You're drowning in a sea of endless email threads, scattered sticky notes, and conflicting deadlines. The team's confused, stakeholders are anxious, and frankly, total project chaos just feels kind of inevitable. But here's the thing, it doesn't have to be.
Because going from utter chaos to absolute clarity, that just requires the right tool. Look, when you've got dozens of moving parts, relying on your memory or, a basic to-do list is a complete recipe for disaster. What you actually need is a visual savior, a way to see time and tasks instantly, literally at a single glance. So, in today's explainer, we're diving into the ultimate tool for turning those overwhelming, mismanaged projects into beautifully orchestrated symphonies of productivity. Yep, we're talking about the Gantt chart.
And we've got a simple, 4-step plan for this explainer. First, what a Gantt chart actually is. Second, we'll look at an example in action. Third, we'll cover milestones and progress tracking. And finally, its advantages and limitations.
All right, let's just dive right in. Section 1. What is a Gantt chart? The big picture.
So, at its core, a Gantt chart is just a visual representation of project activities plotted against time. But think about how profound that simple definition actually is. I mean, we are incredibly visual creatures, right? When we stare at a list of dates on a piece of paper, our brains have to work seriously hard to crunch the math and visualize overlapping schedules. Well, a Gantt chart does all that heavy lifting for us. It takes those abstract, terrifying deadlines and transforms them into a highly visual, tangible timeline. It literally paints a picture of your project's future.
When we break down the anatomy of this thing, it's basically aggregating all your crucial data into one centralized hub. It displays the activities, the actual work. It shows the precise start and finish dates for every single one of those activities, and it visually maps out the duration so you know instantly if a task is going to take 3 days or 3 months. Plus, it tracks progress, showing exactly how much work is actually done. And crucially, this is a big one, it highlights dependencies. It tells you exactly which tasks are stuck waiting for another task to finish. Finally, it plots out your milestones. By pulling all of this into a single coherent view, the Gantt chart just becomes the undisputed single source of truth for your whole team.
Okay, let's move from the theoretical to the practical. Section 2, an example in action, building the board.
Let's walk through a realistic industrial or construction example. Imagine we have a list of raw duration-based activities. We kick off with engineering, which needs 30 days. Next is procurement. That's a lengthy 60 days to source all our materials. Following that, civil work at 45 days, equipment installation at 20 days, testing needs 10, and finally, commissioning the whole project, which takes 15 days. Now, looking at this raw data, sure, you can read the numbers, but you can't really feel the schedule. You don't know off the top of your head when civil work overlaps with procurement, or just how far out commissioning really is. Right now, it's just flat data.
But here is where the magic happens.
In a Gantt chart, those flat numbers make a conceptual leap and suddenly become this living, breathing, graphical timeline. Instead of just reading 60 days, you actually see a long horizontal bar stretching across 2 months of a calendar. You see the 30-day engineering bar sitting right there above it, maybe slightly overlapping. You literally watch the whole project cascade down the page from left to right, kind of like a waterfall of productivity. You can point your finger at any random Tuesday on that calendar axis and know instantly exactly what your team should be working on.
Moving on to Section 3, Milestones and Progress Tracking, Markers of Success. These are absolutely crucial for keeping things moving and keeping morale up.
0. Believe it or not, that is a massive number in project management. Why 0? Well, because milestones are actually critical events that have a duration of exactly 0 days. They aren't tasks you clock in and work on. They're moments in time. They act as fixed markers, like flags planted firmly in the ground.
To give you an idea, let's look at some of these zero-duration markers. Design approved, that's a milestone. Purchase order issued, equipment delivered, installation completed, testing completed, and the big one, project accepted. Notice how every single one of those is a definitive, completed action. They're essentially celebratory checkpoints. When your team looks at the board and sees that little diamond shape for equipment delivered, everyone knows they just cleared a major hurdle. It breaks up those massive, intimidating 60-day or 45-day activity bars into digestible, achievable wins.
And this brings us to how brilliantly dynamic this tool really is. A Gantt chart isn't just some static map you draw up in January and toss in a drawer. It keeps the project alive by constantly comparing your planned progress against your actual progress. Your planned progress is the dream, the baseline you set on day 1. But as we all know too well, reality rarely goes exactly to plan. By overlaying the actual progress, like shading in those activity bars as the work actually gets done, you instantly see if you're pulling ahead, tracking right on time, or slipping behind. It's essentially an early warning system, letting you course correct way before a minor hiccup turns into a full-blown disaster.
All right, bringing us to Section 4, Advantages and Limitations, the verdict. Let's take an objective look at where this tool shines and where it kind of falls short.
The advantages here are pretty undeniable. First off, it's just incredibly easy to understand. You do not need a specialized degree to glance at a visual timeline and get what's happening. And because it's so intuitive, communicating across different departments is an absolute breeze. It's also fantastic for management reporting. I mean, if you need to update stakeholders, handing them a clean visual timeline is infinitely better than dropping a dense 50-page status report on their desk. Plus, as we just saw, it's incredibly useful for tracking delays and visually spotting the gap between the plan and the reality on the ground.
But we've got to be realistic here. There is a notable limitation. A basic Gantt chart may not clearly show complex network relationships. If you're scaling up a project to include thousands of tasks with heavy, intricate dependencies, where task A relies on B, which relies on C, D, and E all at the same time, the basic Gantt chart just hits a wall. The visual layout gets ridiculously cluttered. Suddenly, those clean horizontal bars look like a tangled bowl of spaghetti, and the very clarity that made the tool so great vanishes under the weight of all that complexity.
So what happens when you hit that wall? Well, the source material is super clear on this. For those massive, highly interconnected projects, you need to bring in CPM, the critical path method, and network scheduling. You basically have to upgrade your framework. While a Gantt chart is amazing for mapping out time and straightforward dependencies, CPM is mathematically built to calculate the absolute longest sequence of vital tasks. It pinpoints exactly where you have zero room for error in a massive web of activities. It's the essential next step when you graduate to mega projects.
So here's the bottom line. For the vast majority of standard projects, the Gantt chart really is an unparalleled visual savior. It takes all those abstract elements, the time, the tasks, the looming deadlines, and turns them into a clear, easily navigable map of your future success. It lets you celebrate those zero-duration milestones, track reality against your best-laid plans, and communicate seamlessly with your team. So I'll leave you with this. Looking ahead at your own workflow, is your next big project ready for the absolute clarity of a Gantt chart, or are you just going to keep flying blind?
A Gantt chart is a project management tool. It shows tasks, timelines, dependencies, and progress, helping teams plan and control projects effectively. Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome to another explainer. I am so thrilled to have you here today because we are going to tackle a concept that is an absolute game changer for anyone who organizes, manages, or executes complex work. Whether you're building a skyscraper, launching a new software product, or just trying to pull off a massive corporate event, understanding scheduling is literally everything. Today, we're bringing high energy to a highly effective strategy, the critical path method, or CPM. We're going to break down CPM step by step, look at a really practical example, and show you exactly how to take control of your timelines so you never have to guess where your project actually stands. But hey, before we get into the math and the methods, I want you to ask yourself this. What actually controls your project's completion date? Seriously, think about it for a second. We've all been there, right? Staring down a massive, stressful missed deadline, wondering where it all went wrong, and wishing we had some sort of crystal ball to see which specific delay actually tanked the entire schedule. The truth is, not all tasks are created equal. Knowing exactly what dictates your final delivery date is pretty much the ultimate superpower in project management. To get us to that superpower, here is our roadmap for today. We'll hit 1. Introducing the critical path. 2. Defining the critical path. 3. A step-by-step example. 4. Understanding project float. 5. Why the critical path matters. And 6. The project manager's focus. Okay, let's dive right into this. Section 1, Introducing the critical path, the foundation of scheduling. Let's start with the formal definition. The critical path method, or CPM, is a scheduling technique used to determine the sequence of activities that controls your project completion date. Notice that heavy emphasis on the word sequence. Projects are rarely just one isolated task. They're these complex webs of interconnected, dependent activities. Some things can happen at the exact same time, while others absolutely must happen strictly one after another. And honestly, managing that web can feel completely overwhelming. But CPM, it's the ultimate diagnostic tool. It cuts right through the noise of a busy project dashboard and highlights exactly which sequence of events actually holds the keys to your deadline. Now that we know what the method is trying to achieve, let's move right along to Section 2, Defining the critical path, identifying the longest route. Simply put, the critical path is the longest duration path through the project network. And actually, scratch that, let me repeat it, because it always sounds a bit counterintuitive at first. It is the longest duration path. When we want to get things done fast in our daily lives, we usually look for the absolute shortest route, right? But in project management, the longest sequence of dependent tasks is what determines the absolute earliest date your project can possibly finish. You literally cannot be completely done until this longest chain of events is completely done. It essentially acts as the inflexible spine of your entire project schedule. Now, what's really interesting is what this longest path actually means in everyday practice. Activities on the critical path generally have zero total float. Zero. That means there is absolutely no wiggle room built into them. If a task is on this path, it cannot slip by a single day, an hour, or even a minute without pushing the entire project deadline back by that exact same amount. The stakes for these specific tasks are incredibly high, and identifying them early on, well, that's what separates good managers from great ones.
Conceptual definitions are great and all, but as always, we learn best by doing. So let's move to Section 3, a step-by-step example, putting CPM into practice.
Let's walk through this hypothetical project together. Imagine we're installing a brand new, highly complex piece of machinery in a factory. The sequence of events is strictly linear here, and each step relies entirely on the one right before it. Step 1 is the design phase, which will take exactly 10 days. Once the design is totally locked in, we move to Step 2, procurement. This involves ordering the custom parts, which takes 20 days. When those parts finally arrive on the loading dock, we hit Step 3, installation, taking 15 days of intensive labor. And finally, we finish up with Step 4, testing, which takes 5 days to ensure everything is running safely before we hand over the keys. So if we add those up, 10 days for design, plus 20 for procurement, plus 15 for installation, plus 5 for testing, we get our total project duration for this path, 50 days. I really want to anchor that number for a second. That sequence takes 50 straight days of work to complete. It sets the absolute baseline for when this machinery will be fully operational. And this brilliantly illustrates why the longest path is totally the boss. Imagine that alongside our 50-day machinery installation, we also have a separate, totally independent team painting the factory floor. Let's call that the alternative path. And their sequence of painting and drying tasks only takes 40 days. Well, even if the painters finish completely on time in 40 days, the project as a whole just isn't done. The machinery team still has 10 days left of work. The 50-day path is the longest, so it dictates the true schedule. That makes the 50-day sequence the critical path and renders that 40-day path non-critical. So, what exactly happens to the tasks on that shorter 40-day path? Do those guys just sit around? Well, that leads us perfectly into Section 4, Understanding Project Float, Finding Your Wiggle Room. Float is the amount of time an activity can be delayed without affecting a defined project milestone or the final completion date. Remember our factory painters? Their path takes 40 days, but the overall project has 50 days to complete. That means they have 10 days of float. They could literally start 10 days late, or a single task could take 10 days longer than expected, and that final 50-day project deadline will not shift by a single second. Float gives you flexibility. It allows a project manager to breathe a little bit. It is a massive contrast to that rigid, highly stressful, zero total float of the critical path we were just talking about. Now, understanding the math is one thing, but understanding the consequences is a whole different ballgame. Let's move to Section 5, Why Critical Path Matters, the Real-World Stakes.
Here is the absolutely crucial point. If a critical activity is delayed by 5 days, and this is vital, if no recovery action is taken, the project is delayed by 5 days. You cannot hide a delay on the critical path. If your procurement step from our earlier example takes 25 days instead of 20, your entire 50-day project becomes a 55-day project instantly. Without paying expensive overtime to crash the schedule or overlapping tasks in a highly risky maneuver, a delay on the critical path is a guaranteed delay for the entire project. There is nowhere to hide.
Knowing how incredibly high the stakes are for these zero-float activities, how should a leader adapt their daily strategy? Let's transition to our final section, the project manager's focus, where to direct your energy. As a manager, your time is strictly limited, right? So you have to guard the critical path aggressively. Critical activities should receive your closest attention, specifically regarding these 6 areas. First, resources. Are your absolute best, most reliable people assigned to these critical tasks? You just can't afford a weak link here. Second, procurement. Are you personally tracking the shipping numbers and customs clearances for materials on this path? Third, technical issues. If a bug or a glitch pops up here, it requires an immediate all-hands-on-deck response. Fourth, approvals. Don't let a critical task sit on a manager's desk waiting for a signature. Literally walk it into their office yourself. And finally, safety and quality. Why? Because an accident or a failed quality inspection on the critical path stops the entire project dead in its tracks while you rework it. You have got to proactively manage all 6 of these risks. Bringing the whole shebang together, here is the key takeaway you should capture today. The critical path method helps project managers understand exactly which activities have the greatest influence on project completion. It shifts you from being completely reactive, just running around putting out whatever fire is the loudest, to being highly proactive, managing the specific sequence of events that actually dictates your success. It's all about strategic, targeted focus.
I want to thank you so much for joining me to explore the mechanics of scheduling today. And I want to leave you with this provocative final thought to carry into your very next team meeting. Are you actually focusing your energy on the path that dictates your deadline, or are you just burning time managing the float? Think about it, apply it to your workflows today, and keep learning. See you next time.
Critical Path Method identifies the longest sequence of dependent activities that determines the minimum project completion time.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome back, everyone. Look, if you have ever felt that, well, that universal sinking feeling in your gut when you realize a project is definitely going to miss its deadline, mostly because just a couple of key tasks took wildly longer than expected, yeah, you are in exactly the right place. Today's explainer is entirely focused on solving that exact pain point. We're looking at a brilliant, highly structured way to estimate project duration when you're dealing with a heavy dose of uncertainty. We are essentially going to tame the unpredictable.
So here is our roadmap for today's explainer. Number 1, what is PERT? 2, 3 estimates. 3, the PERT formula. 4, why use PERT? 5, CPM versus PERT. And 6, key takeaway.
Okay, let's dive into Section 1. What is PERT? Tackling Project Uncertainty.
All right, so PERT stands for Program Evaluation and Review Technique. And listen, if there is just one single word you remember from this entire explainer, it really should be that last word on the slide, uncertain. This whole framework exists because, let's face it, in the real world, things rarely go exactly to plan. When you're mapping out a project and you simply do not know how long a specific activity is going to take, this is the project management method you reach for. It is designed from the ground up for uncertainty.
Moving right along to Section 2, 3 estimates, the core of PERT. Instead of forcing you to just guess one single number out of thin air for a task, PERT asks you for 3 totally separate estimates. First up, the optimistic duration, represented by the letter O. This is your absolute best-case scenario, like if the stars align, nobody gets sick, and traffic is perfect, how fast can this get done? Second is the most likely duration, or M. This is your normal, day-to-day expected duration if things go, as they usually do. And finally, the pessimistic duration, represented by P. This is your worst-case scenario. If absolutely the whole shebang goes wrong, how long will this take? By breaking it down this way, we're actually capturing the full messy range of reality.
Which brings us to Section 3, the PERT formula, calculating expected duration. Now, what's really interesting about this slide is how we take those 3 very different guesses and turn them into one rock-solid timeline. This is the formula for calculating expected duration, or TE. It looks like this. TE equals O plus 4 times M plus P all divided by 6. Now, I don't want you to just memorize this, right? I want you to really understand it. Look at the middle part there, 4M. We are heavily weighting the most likely estimate. We multiply it by 4 to ground our final number in reality, ensuring that the extreme best case and worst case guesses don't completely hijack the math. Then we add those all up and divide by 6 because we've essentially created 6 parts, 1 O, 4 M's, and 1 P.
Let's look at a highly concrete, hypothetical example so you can actually see this in action. Let's say you have a really tricky project task. You sit down with your team and you all agree that the optimistic scenario, the absolute best case, is 4 days. The most likely scenario, your normal expectation, is 6 days. But if everything falls apart, your pessimistic worst-case scenario is 10 days. Boom! We now have our inputs perfectly organized before we even touch a calculator. Let's move to the math and see how this builds step by step. Step 1. We plug our values directly into the formula. So TE equals 4, plus 4 times 6, plus 10, all divided by 6. Step 2. We do the multiplication for our heavily weighted most likely value. 4 times 6 is 24. So now our equation is looking like 4 plus 24 plus 10, all divided by 6. Step 3, we add those top values together, which gives us 38. And then we just divide that 38 by 6.
And there is our payoff, 6.33 days. Think about what we just did there. We took a situation where the team was basically throwing their hands up, completely unsure if the task would take 4 days or almost 2 whole weeks, and we turned it into a highly actionable, mathematically sound expectation of 6.33 days. It literally takes a dry calculation and turns it into a project manager's best friend.
All right, Section 4, why use PERT? Real-world application.
So here is where this calculation truly shines. You're going to want to use PERT for research projects when you're implementing new technology, during complex engineering work, or for equipment commissioning. Ultimately, it all comes down to first-time activities and projects with uncertain durations. The big common thread tying all of these together is simply the unknown. If you've never done a specific task before, or you're literally inventing something new, you can't just slap a standard expected completion date on it. You really need the flexibility that PERT provides.
Let's move to Section 5, CPM versus PERT, choosing the right tool.
Now, this perfectly illustrates the exact difference. The critical path method, or CPM, is fantastic, for sure, but it generally works well only when activity durations are relatively predictable. If you are building your 100th identical suburban house, you use CPM because you know exactly how long pouring that foundation takes. But for PERT, think about building a custom research facility on the side of a mountain. You use PERT when activity durations involve significant uncertainty. It's all about pulling the right tool out of your toolkit for the specific job right in front of you.
Finally, Section 6, key takeaway, the ultimate value of PERT.
So the crucial point is right here, directly from our source material, and it honestly hits the nail on the head. Quote, PERT provides a more realistic approach to estimating project duration when uncertainty is significant. It's not just some abstract equation on a whiteboard. It is a highly practical, deeply realistic way to tame project chaos and give your team a reliable schedule that they can actually believe in.
Which leaves me with a question for you to think about as we wrap up today's explainer. Take a look at the work sitting on your desk right now. Is your next project's timeline truly predictable, or are you kind of just guessing? If you're guessing, well, it might just be time to use PERT.
Thanks so much for joining me for this explainer, and I really hope this makes managing your next complex project a whole lot easier.
PERT is a project scheduling technique used when activity durations are uncertain. It uses 3 time estimates to calculate the expected activity duration. Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
All right, let's jump right in. Welcome to the explainer. Today, we've got an absolutely fantastic topic lined up for you. You know, if you've ever wondered how large-scale projects, or frankly even the small ones, actually get across the finish line without just completely falling apart, well, it all comes down to what we're looking at today: project resource management. We're going to break down exactly how you manage your people, your equipment, and your materials to get the job done right, efficiently, and on time.
Okay, let's dive into this. Even a perfect schedule can fail if the required resources are unavailable. I love starting with this because it hits the nail on the head. This is the ultimate project deal breaker. Think about it. You can have the most beautiful Gantt chart in the world, a totally flawless timeline, brilliant ideas, but if the people or the tools you need just aren't there when you need them, there's no way around it. The whole thing grinds to a halt. Mastering resource availability isn't just some boring administrative task. It is literally the lifeblood of your project.
So, here's our roadmap for today. First, defining resource management. Second, managing human resources. Third, the racing matrix. Fourth, resource loading. And finally, constraints and leveling. Let's get started.
Section 1. Defining resource management. What exactly are we managing here?
Well, here's the foundational definition we need to keep in our back pockets throughout this entire explainer. Resource management is the process of planning, allocating, and controlling the resources required to complete a project. Notice those 3 distinct verbs, right? It's not just about casually having stuff on hand. It's about rigorously planning for things ahead of time, actively allocating them to exactly where they need to go, and then controlling them as the project moves forward to make sure they're actually being used properly.
And when we use the word resources, it's absolutely crucial to realize we're talking about a much broader category than just the cash sitting in a project budget. There are 7 main types of resources we have to track. We've got people, equipment, and materials. But we also have to account for specific tools, the physical facilities where the work is actually happening, the money, and of course, technology. If you miss planning for even one of these, say, you've got the people and the facility, but you totally forgot to allocate the specific software licenses they need, yeah, your project is going to stall on day 1.
Section 2. Managing human resources. Let's look at the most complex resource of all.
When identifying the human element of your project, you really can't just count heads. I mean, having 10 people in a room doesn't mean you have the right 10 people to get the job done. You've got to consider this specific list of requirements. You need to identify the exact required manpower, sure, but what about the specific skills those individuals possess? What are their designated responsibilities going to be? What's their actual availability during your specific timeline? And finally, do they have any training requirements that need to be checked off before they can even safely begin the work? So, human resources management is really all about ensuring a precise, tailored fit for your project's unique needs.
Section 3. The Rossi matrix. Once you have your people, how do you organize them?
Now, what's really interesting about this matrix is how it creates the ultimate accountability framework for your team. RACI stands for responsible, accountable, consulted, and informed. For every single task in your project, you map out who is responsible for actually doing the physical or mental work, who is accountable for the final outcome, which, let's be honest, is usually just the one person whose head is on the chopping block if things go wrong, then who needs to be consulted for their expert input before the task is finished, and finally, who just needs to be kept informed about the progress. When you actively use this, role confusion pretty much disappears entirely.
Section 4. Resource loading. Moving from who is doing the work to exactly how much we need.
Resource loading is formally defined as identifying how much resources required for each activity. Honestly, this is where the math really happens. You're moving from a general plan into quantifying the absolute exact needs for every single solitary activity. It's just not enough to say to your boss, hey, we're going to need some technicians for this phase. No way. You have to load the activity with precise numbers. To put that into perspective, take a team coming together on a site for an equipment installation. Resource loading maps out the exact combination of humans, machines, and tools required for just this one task. For this installation, the load is precisely 1 engineer, 2 supervisors, 6 technicians, 1 crane, specific welding equipment, and lifting tools. Imagine a scenario where you just ordered, a crew and some heavy equipment. The crane might show up without the lifting tools, or you might have 6 highly paid technicians just standing around without a supervisor to guide them. Resource loading paints the complete, mathematically precise picture of what success actually looks like on the ground.
Section 5. Constraints and leveling. Because things never go perfectly according to plan.
So what happens when resources run short? What happens when reality literally hits the spreadsheet? Let's pivot into the troubleshooting phase here, because anticipating these problems is just as important as all that initial planning we were just talking about.
These are the common resource constraints you are almost certainly going to face at some point. Limited manpower, sudden equipment shortages, totally frustrating material delays, budget limitations, or an unexpected skill shortage. Remember these. These are the exact obstacles that will derail that perfect schedule we talked about at the very start of the explainer. You might have rigorously planned for that crane in your resource loading, but what if the rental company has an equipment shortage that day? Or, actually, what if your one designated engineer just calls in sick, creating an immediate skill shortage? Boom, you're suddenly constrained and your whole project is at risk.
And this brilliantly illustrates why we need our final conceptual tool, resource leveling. Resource leveling is defined as adjusting activities to avoid resource overallocation. Think of it as the critical adjustment tool that basically saves the day when you've accidentally stretched your team or your equipment way too thin. If that crane is delayed, leveling means looking at your schedule and smoothing things out. Maybe you delay a non-critical task in order to free up those 6 technicians for the main installation once the crane finally does arrive. You're actively leveling the workload so that no single resource is overallocated, double-booked, or pushed past its breaking point. It's how you fix the mess.
Which leaves us with this final provocative thought to ponder. Is your perfect schedule actually built to survive the harsh reality of resource constraints? Because as we've seen today, resource management isn't just about listing what you want. It's about allocating exactly what you need across 7 different categories, defining crystal clear accountability with the RACI matrix, loading your tasks with mathematical precision, and knowing exactly how to level the playing field when constraints inevitably pop up. I highly encourage you to take these building blocks and apply them to your own future projects. Thanks so much for joining me on this explainer. Keep learning, and we will see you next time.
Project resource management is the process of identifying, acquiring, and managing the resources needed to successfully complete a project. In PMP, resources include both team. Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Let's get right into it, shall we? Today, we are taking a deep dive into the absolute lifeline of any successful project, keeping those finances on track. Look, whether you're managing a massive commercial construction build or rolling out a complex new software platform, knowing how to truly manage your costs is an absolutely crucial skill. So let's unpack exactly how this process works in the real world. Here's our roadmap for this walkthrough. We'll start with defining what cost management actually is, explore some typical cost categories, and look at estimating and budgeting. Then we'll dive into controlling those costs, and finally, we'll walk through an eye-opening example using earned value.
What is cost management?
You know, when you're staring down the barrel of a massive new project, the financial side can honestly seem pretty overwhelming. It's like a giant puzzle. But if we break down what cost management exactly is, you'll see it's actually a highly logical, structured process.
It basically boils down to 3 core pillars. First up, you've got estimating costs, literally figuring out what every single piece of the puzzle is going to cost you. Then, developing budgets, which means rolling all those individual estimates up into one master financial plan. And third, controlling costs, which is all about making sure you actually stick to that plan once the real work kicks off. Put them together and they form a clear, chronological roadmap for your project's money.
Part 2, typical cost categories.
Now, when you're in that estimation phase, the sheer scale of what you need to track is massive. It is almost never just labor and materials. Oh no, you have to account for initial engineering, equipment, procurement, construction, and testing. And don't forget commissioning, end-user training, and outside consultants. It's a huge web of expenses spanning from the very first drawing board sketch all the way to the final handover.
Moving on to Part 3, estimating and budgeting.
So how do we actually figure out all those numbers? Well, there are 5 go-to methods we can rely on. You might look at historical data from past projects or just get direct vendor quotations. You can use analogous estimation, comparing it to similar work, or parametric estimation, which uses statistical modeling. Or, if you need to be incredibly precise, you go with a bottom-up estimation, meticulously building the budget from the absolute smallest task upward.
But here is the critical part. Once all those estimates are compiled and get the official stamp of approval, they lock in to form what's called your cost baseline. Think of this baseline as your ultimate yardstick. Every single dollar you actually spend on the project from this point forward is going to be judged against it.
Which brings us right into Part 4, Controlling Project Costs.
Now we are in the execution phase, where the rubber meets the road. During this time, project managers have to obsessively monitor the daily clash between the budgeted cost and the actual cost. You are constantly holding up that golden cost baseline and comparing it against the cold, hard cash actually leaving your accounts.
Finally, Part 5, the earned value example.
To see how this plays out, let's walk through a scenario, because honestly, just looking at budgeted versus actual costs can trap you. Imagine your approved cost baseline is set at a nice clean $1 million. You've done the math, you've got the green light, and the project is off and running.
Fast forward a bit, you are deep in the weeds of execution. You open up your books to check your financial health, and you see you've actually spent $850,000 so far. Basic math tells us, hey, we have $150,000 left. It is so easy to glance at those numbers and think, awesome, we've still got money in the bank. We're totally fine, right? But hold on, because that simplistic view is giving you a massive, false sense of security. Here is where the real problem rears its head. You go out and actually review the project milestones, and you realize only 60% of the physical work is complete. Think about that. You've burned through 85% of your total budget, but you still have 40% of the actual work remaining. You don't just have a minor issue here. You have a critical 5-alarm cost problem. And that terrifying blind spot is exactly why earned value management was created. EVM is an absolute game changer because it ties your costs directly to the work that has actually been completed. It forces us to stop asking what did we spend and start asking what value did we actually earn for what we spent. I want to leave you with this incredibly powerful takeaway from our source material. It says, cost management is not simply tracking how much money has been spent. It is understanding whether the money spent is producing the expected project progress. That really hits the nail on the head, doesn't it? So, as you gear up for your very next project, I want you to ask yourself a hard question. Are you just tracking your pennies out the door, or are you actually measuring real progress?
Project cost management ensures the project stays within budget. Estimate costs, set the budget, and control spending to deliver the project successfully. Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Okay, let's dive into this. Welcome to today's explainer, where we're going to unpack project risk management explained. Identify, analyze, and control project risks. You know, whether you're leading a massive construction build, rolling out a complex new software platform, or even just organizing a global event, risk is always going to be your constant companion. It's just a fact of life. But here's the secret. Risk doesn't actually have to be your enemy. The source material we're looking at today promises to totally transform the way we view uncertainty. We're going to turn it from a constant worry into something we can systematically control.
To get started, we have to ask ourselves a very fundamental question. What exactly is a project risk? I mean, think about how you normally react to problems on a project. Most of us, right, we operate in this constant state of firefighting. We're running around with a bucket of water just hoping the next disaster isn't too big. We kind of view risk as just a synonym for disaster. But to truly get a handle on project management, we need to completely shift our mindset. We need to move away from reacting to disasters after they happen and shift toward proactively controlling uncertainty before it ever has the chance to derail our hard work.
So, the crucial point is right here in the foundational definition. A project risk is an uncertain event or condition that may affect project objectives. I really want to emphasize those two words, uncertain event. You see, a risk is not a problem that's currently happening. If your server just crashed, well, that's an issue. That's a reality. A risk is the uncertainty that the server might crash tomorrow. By recognizing that risk lives purely in the realm of uncertainty, we give ourselves the power to prepare for it, shape it, and honestly, sometimes even prevent it entirely. Now, you might be wondering, why does this matter to you in your daily workflow? Well, because when that uncertain event actually happens, it doesn't just vanish into thin air. It directly strikes at the core of your project. Risk can hit any of the core pillars we have: cost, schedule, scope, quality, safety, and performance. These 6 areas are literally the universal indicators of project success or failure. If a risk materializes, it might mean your budget blows up, your timeline stretches out by months, or worse, the safety of your team is compromised. By mastering risk management, you're essentially building an invisible fortress around these 6 vital metrics.
To build that fortress, the research shows that professionals absolutely do not rely on gut feelings. Instead, they use this 5-step risk management process: identify, analyze, evaluate, develop responses, and monitor. This right here is the professional's ultimate weapon to logically map the journey of controlling chaos. You start by identifying the risks, just brainstorming everything that could possibly go wrong. Then you analyze and evaluate them to really understand their true nature. Next up, you develop responses, which is crafting your game plan. And finally, you monitor them continuously, because risks are dynamic, right? They change as your project evolves. It's a continuous, strategic loop.
Let's zoom in on how we actually evaluate those risks once we've identified them. You can't treat every single risk as a 5-alarm fire, or you're going to exhaust your entire team in a week. Risk is commonly evaluated using a very straightforward risk matrix formula: probability multiplied by impact. Basically, how likely is this uncertain event to happen, and if it does happen, how bad is the damage going to be? By multiplying these 2 factors together, we can mathematically separate the minor hiccups from the absolute project-killing catastrophes.
Let's look at the life cycle of a risk by applying that exact formula to a real-world example from our source material. Imagine you're waiting on a crucial piece of equipment. You evaluate the situation and realize, okay, there is a high probability of a delivery delay. You also know that if it is delayed, it's going to have a high impact on your overall schedule, literally bringing everything to a grinding halt. High probability multiplied by high schedule impact equals a high priority risk. It's no longer just a vague worry in the back of your mind, it's a mathematically proven critical threat that demands your immediate attention.
Now, what's really interesting about this slide is how we take all that theory and put it into a highly actionable tool, the risk register. Notice how we don't just log threats like a material delay or an equipment failure with their probabilities and impacts. Look at those last 2 columns. This is where the magic actually happens. We dictate a specific response, like early procurement or securing backup equipment. And most importantly, we assign an owner. This ensures total accountability. A risk without an owner is honestly just a disaster waiting to happen.
So we've got our risk register, we've done our math, and we have our owners assigned. That naturally leads us to the next massive phase of the process. How do we actually respond to these threats? Because let's be real, logging them on a spreadsheet and just hoping for the best isn't project management. That's just wishful thinking. We need concrete strategies.
The first response strategy for dealing with a threat is to avoid it. Avoiding a risk means you completely change the project plan so the risk is eliminated entirely. For instance, if a specific vendor is highly unstable and poses a massive risk to your schedule, you avoid the risk by dropping them completely. You literally cross the street so you and the risk don't bump into each other. You're altering your path so that the project and the risk never intersect.
Let's move to and see how this builds into our second strategy, mitigate. Because you can't always just avoid a risk without compromising the project's goals, right? Mitigation is where we proactively soften the blow or lower the chances of the risk happening at all. Say you're building during a rainy season. You can't avoid the rain, but you can mitigate the schedule impact by putting up a temporary roof. You're actively working to reduce either the probability of the event occurring or the impact it'll have when it does. Our third strategy is to transfer the risk. This means shifting the burden and the responsibility over to a third party. You aren't eliminating the risk, but you are ensuring someone else takes the hit if things go south. The most common examples of this, as our source notes, are purchasing insurance or drafting very specific contracts that place the financial burden of a delay squarely on a subcontractor. You're transferring that impact right away from your own baseline.
Finally, we have the fourth strategy, accept. Sometimes, a risk simply isn't worth the headache or the cost of fixing. If the probability is incredibly low or the impact is negligible, the most strategic professional move is to just acknowledge it, document it, and accept it, because further action just isn't justified. You go in with your eyes wide open, knowing you'll just live with the consequences if it happens.
And this brilliantly illustrates a key takeaway quote straight from our source material that really captures this entire philosophy perfectly. Professional project management does not wait for problems to occur. It identifies potential problems early and prepares responses. This right here is the climax of our explainer. It all comes down to a proactive mindset. Amateurs react to the unexpected. Professionals, they anticipate the unexpected, calculate the probability, assign an owner, and have a strategy ready to deploy before the first sign of trouble even appears.
So, I want to leave you with a bit of a challenge as we wrap up this explainer. Look at the projects you're currently managing or the ones you're just about to kick off, and ask yourself, what risks haven't you prepared for yet? Where exactly is your uncertainty living? Take that 5-step process, build out your matrix, populate your risk register, and decide right now whether you're going to avoid, mitigate, transfer, or accept those threats. Don't wait for the problems to occur. Take control of your project's future today.
Project risk management means identifying, analyzing, and responding to risks before they impact project objectives. The goal is to reduce threats and maximize opportunities.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome to this explainer. Okay, we've all been there, right? You see a project that looks absolutely perfect on paper, only to watch it completely stumble right at the finish line. You put in the hard work, the crazy late nights, you stretch those tight budgets to the absolute limit, but how do you actually guarantee it results in exactly what was promised? Well, today we are diving deep into project quality management. And more importantly, we're going to make that notoriously misunderstood difference between quality assurance and quality control incredibly simple to grasp. At its core, quality management is all about ensuring that project deliverables meet defined requirements. Now, what's really interesting here is that when you strip away all that corporate jargon, quality management isn't just some abstract buzzword you throw around in a meeting to sound smart. It's a rigid, dedicated system. It's literally a commitment to guaranteeing that absolutely every single deliverable you hand over meets its exact agreed-upon requirements. There's no guesswork here, and there is certainly no close enough. So, here is our roadmap for the day. We're going to cover 1. What is quality management? 2. Quality planning. 3. QA versus QC explained. 4. A real-world example focusing on welding. 5. Common quality tools. And finally, 6. The golden rule. We're going to break this whole thing down piece by piece. All right, section 1. What is quality management? Let's jump right into the core framework that makes up your overall quality strategy. Quality management actually breaks down into 3 vitally important interconnected steps. 1. Quality planning. 2. Quality assurance. And 3. Quality control. You know, it's absolutely crucial to realize that managing quality isn't just some final hurdle you jump over at the very end of a project. It's a chronological flow. You plan for it, you assure that you're doing things right along the way, and then finally, you control the output. These 3 pillars have to work together. Which brings us to section 2, quality planning. This is the crucial first phase where we lay the concrete foundation before a single drop of actual work begins. To guarantee success, you've got to strictly define your baseline right up front. You need to define the following: standards, specifications, acceptance criteria, which, by the way, tells you exactly what done actually looks like, inspection requirements, and testing requirements. You simply cannot hit a target that you haven't clearly drawn. Literally, if you don't define what tests your product needs to pass on day 1, you're just setting yourself up for total failure on day 100. Everything starts with this plan. Moving on to section 3, QA vs QC explained. Get ready because we are about to tackle the biggest area of confusion for professionals across pretty much every industry. Here's the ultimate distinction, side by side. Quality assurance focuses on the process versus quality control, which focuses on the actual result. QA is a highly process-oriented discipline. It's all about how you are doing the work. QC, on the other hand, is strictly results-oriented. It's looking at what you actually produced. Process versus result. Actually, just keep that firmly in your mind as we go forward. To make this even clearer, just ask yourself this one simple question for quality assurance. Are we following the correct process? I really want to plant this specific rhetorical question in your mind as the ultimate litmus test for QA. When you're doing quality assurance, you aren't looking at the final product yet. You're looking at the rulebook, essentially checking if the team is actually reading it, right? You're making absolutely sure the steps being taken are the right ones.
Then, immediately following that, we have our quality control question. Does the product meet the required specification? Notice the big shift here. This step is entirely about evaluating the tangible output. The work has been done, the item's been built, the code's been written. Now, QC steps in to measure that actual result against the specific rules we defined all the way back in the planning phase.
Let's look at Section 4, Real-World Example, Welding. We're going to anchor these abstract concepts in a highly tangible industrial setting, just to vividly demonstrate how this whole thing works in reality. So, QA for welding. In an industrial setting like this, QA doesn't even look at a finished weld. Instead, it ensures approved procedures exist, guarantees qualified welders are used, and verifies inspection procedures are followed. Basically, QA is making sure all the right procedures and all the right people are perfectly in place before a single spark even flies. Conversely, look at QC for welding. QC steps in after the fact. It's there to verify weld quality, check dimensions, conduct visual inspection, and analyze NDT, or non-destructive testing results. Do you see the difference there? QA made sure the welder was actually qualified to do the job. QC is checking the physical weld that the welder left behind to make totally sure it won't break. Okay, let's zoom out a bit for Section 5, Common Quality Tools. We're going to give you a practical toolbox that you can take right back to your own workflows. Whether you lean more into assurance or control, you're going to rely on tools like an inspection checklist, an NCR, an audit, and test reports. And hey, when things inevitably go wrong, because they always do, right? You've got powerful investigative methods at your disposal, like root cause analysis, Pareto analysis, or the fishbone diagram. These aren't just theoretical terms. They are the actual day-to-day instruments you use to enforce the standards we've been talking about. Now for Section 6, Key Takeaway. We've covered the definitions, the processes, and the tools, so let's prepare for a major paradigm shift regarding how you traditionally view the concept of quality. Here is the bottom line, and a great quote to remember. Quality should be built into the project rather than inspected only at the end. This is the ultimate takeaway from this entire explainer. That old mindset of just, building something fast and letting the inspectors sort out the mess at the finish line, it's fundamentally flawed. You literally cannot inspect quality into a bad product. It has to be built into the process through diligent planning and strict quality assurance, long before quality control ever even touches it. Which brings us to our final question for today, and I really want to leave you pondering this. If you only inspect at the end, what are you too late to fix? Just think about all the wasted time, the wasted materials, and the blown budgets that could have been completely saved if quality was assured during the process, rather than just controlled at the very end. I highly encourage you to look at your own workflows, maybe restructure your approach, and start building quality in from day one. Thanks so much for joining me for this explainer, and keep building great things.
Project quality management ensures that project work meets the required standards through quality planning, assurance, and control.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome back to another explainer. So, have you ever watched a project kick off with massive enthusiasm, a total rockstar team, and a really healthy budget, only to watch it slowly drift off course until it just crashes and burns? Yeah, it happens literally every day in business. Today, we're talking about the absolute ultimate survival skill for any initiative, which is keeping your projects alive and healthy. We're going to be looking really closely at project progress monitoring and specifically focusing on planned versus actual progress. Okay, let's dive into this. Here's our roadmap for today. 1. What is progress monitoring? 2. The key questions. 3. Planned versus actual. 4. Progress measurement and meetings. And finally, number 5. Executing a recovery plan. Starting right off with part 1, what is progress monitoring? Keeping the project on track. At its absolute core, progress monitoring is defined as determining whether the project is progressing according to the approved plan. Think of it kind of like a doctor regularly checking a patient's vital signs. You aren't just looking at the patient when they arrive and then again when they're discharged, right? You're constantly, methodically measuring their pulse against a healthy baseline. And in projects, well, this is really the only way to ensure everything is actually going according to that original approved roadmap. Moving right along to part 2, the key questions. 5 crucial inquiries. Honestly, Everything begins with this one urgent, overarching dilemma. Is your project on track, or is it falling behind? Put yourself directly into the mindset of an anxious project manager right now. You've got stakeholders demanding updates, teams just waiting for direction, and a firm, completely unforgiving deadline looming on the calendar. You absolutely need clarity on this fundamental question before you can make even a single operational decision.
Now, what's really interesting about this breakdown is how perfectly it sequences from initial observation all the way down to necessary action. Every project manager should be asking these 5 specific questions. First, what was planned? Second, what has actually been completed? Third, what is delayed? Fourth, why is it delayed? And fifth, what action is required? Notice how perfectly this sequences your thought process. You don't just jump to panicked conclusions. You start with objective observation, right? Comparing the baseline plan to actual completion. Then you identify the specific delays, investigate the root causes of those delays, and only then do you determine the required action. It's just a flawless diagnostic loop.
Which brings us to part 3, planned versus actual, the reality check. Let's look at a pretty common scenario. Say you're building a new app, and your approved plan dictates that you should be at 70% completion today. That's the expectation. But on the ground, your actual progress is only 60%. Now, I want to pause here for a second to let you really grasp that gap. The code that's actually written simply does not match the promise that was made on paper.
So the crucial point is we are left with a negative 10% variance. This dramatic shortfall officially signals that the project is behind plan. It removes all the guesswork and, frankly, all the blind optimism from the room. The hard math tells us there's a 10% gap, and well, the alarm bells should absolutely be ringing.
Let's jump into part 4, progress measurement and meetings, gathering data and taking action.
To find out if you even have a variance in the first place, you need to measure the work. Here is a super digestible toolbox of 5 progress measurement methods used to collect that critical data. We've got the milestone method, percentage completion, weighted progress, physical measurement, and earned value management, which, by the way, is really just a fancy way of measuring project performance against the project budget. A good project manager relies on these exact methods to turn really complex, messy daily tasks into clean, tangible data points. It is the only way to accurately lock in that actual progress number. Once you've collected your data using those measurement methods, you bring it to the weekly progress meeting. A professional progress meeting agenda should be highly structured, basically divided into looking back and looking forward. When looking back, the team discusses previous action items, actual progress, delays, quality issues, and resource issues. Then they immediately pivot to looking forward, discussing planned work, risks, procurement, recovery actions, and next week's plan. And this brilliantly illustrates how discussing the past immediately informs the future. You systematically unpack the delays and resource issues of yesterday so you can effectively strategize the planned work and recovery actions of tomorrow.
Finally, part 5, executing a recovery plan, getting back on course.
When you're staring down a negative variance, you need actual real-world solutions. Let's look at the strategic toolkit of recovery actions and see how this builds a concrete path to saving a delayed project. Step 1 is to increase labor, so that means bringing in additional manpower, scheduling extra shifts, or approving overtime. Step 2 is to run parallel activities. Instead of waiting for, say, the electrical work to finish before starting the plumbing, you figure out a way to do both at once. Step 3 focuses on the supply chain, expediting procurement or utilizing alternative suppliers to get your materials faster. And Step 4 is engaging in deep technical problem solving to just clear out any roadblocks in your way. All of those preceding lists, the measurement methods, the weekly meetings, and those recovery steps we just explored, they all ground themselves in this single, really powerful real-world takeaway. Progress monitoring transforms project data into management decisions. See, without monitoring, a negative 10% variance is just a scary piece of trivia. But with it, that data point becomes the exact justification you need to authorize overtime, hire an alternative supplier, or just completely restructure your entire week's plan.
To wrap up our explainer today, I want to leave you with this final, genuinely provocative thought. If you don't know where your project is today, how will you know where it's going tomorrow? Think about the initiatives you're managing or even just contributing to right now. Are you truly monitoring the planned versus actual progress? Or are you just sort of hoping everything works out in the end? Apply these measurement methods, ask those 5 crucial questions, and always, always be ready with a recovery plan. Thank you so much for diving into this with me, and keep your projects on track.
Project progress monitoring compares planned versus actual performance, identifies delays, and enables timely corrective action to keep the project on schedule. Team, let's Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome to the Explainer. Have you ever looked at a massive project and felt totally lost trying to figure out if it's actually healthy? Like, sure, you might have money left in the budget, but are you secretly weeks behind schedule? Well, today, we're unlocking the absolute ultimate tool for project performance, earned value management. And hey, if you've ever felt intimidated by project math, seriously, don't sweat it. By the end of this Explainer, you're going to see exactly how to diagnose the true health of literally any project. Okay, let's quickly look at our roadmap. We're covering 1. What is EVM? 2. The 3 fundamental values. 3. Calculating project variances. 4. Project performance indices. And 5. EVM in action with a real-world example. All right, let's dive right into section 1. What exactly is EVM? To really get EVM, we first have to recognize this universal nightmare that basically every business faces. I want you to ask yourself, is your project actually on track? Seriously, think about it. Imagine you're managing a major rollout. You pull up your budget report, and hey, you haven't spent all your money yet. Looks great, right? But does that mean you're doing a good job? Or does it just mean your team is moving at a snail's pace and nothing is actually getting done? That uncertainty right there is a massive problem for project practitioners. And that is exactly where EVM comes to the rescue. Earned value management is the ultimate diagnostic tool because it pulls everything together into one crystal clear picture. It's a performance measurement technique that tightly integrates scope, schedule, and cost. So instead of looking at your timeline on one screen and your accounting spreadsheet on another, EVM forces you to smash them together. It basically asks, for the cash we just burned, did we actually get the work done that we promised by today? Moving right along to section 2, the 3 fundamental values. Okay, everything in EVM math relies on 3 core acronyms. Think of these as the DNA of your project. Let's translate these into plain English because they're the absolute foundation of everything we're about to do. First up is PV, or planned value. This is simply the budgeted value of the work you plan to do. Basically, by today, what did I plan to have finished and what was that supposed to cost? Second, we have EV, earned value. This is the budgeted value of your completed work. In other words, look at what we physically finished today. Based on our original budget, how much is that finished work worth? That's the value you've actually earned. Finally, AC, actual cost. Simplest one of the bunch. It's the actual, real-world cost incurred for that completed work. When you check the receipts, how much cash physically left your bank account. What we planned, what we earned, and what we actually spent. Lock those 3 ideas in. Let's keep building. Section 3, calculating project variances. Now we're going to shift gears and see how subtracting these fundamental values lets us take the project's vital signs. We call these variances. And check out the brilliant symmetry here between schedule variance and cost variance. Notice anything? Earned value, EV, is always the very first number. To find your schedule variance, you take what you earned and subtract what you planned, EV minus PV. For cost variance, you take what you earned and subtract what you actually spent, EV minus AC. The core logic never changes. What did we get minus what did we plan or spend?
Now here is where it gets really fun. These formulas give us literal cheat codes for diagnosing if those variance numbers are good or bad. If your variance is greater than 0, a positive number, you are ahead of schedule or under budget. That's fantastic news. If your variance equals exactly 0, you are perfectly on target. And if your variance is less than 0, a negative number, well, you're behind schedule or over budget. It's incredibly intuitive. Positive is good, negative is bad. It's really that simple.
All right, on to section 4, project performance indices.
This is the next logical step. Instead of subtracting the numbers like we just did, we're going to divide them to find our efficiency rates. See, while variances give us raw dollar amounts, like, hey, we're 50 grand over budget, indices give us powerful ratios to measure exact project efficiency. And again, look at that symmetry. Earned value is always sitting right there on top of the fraction. For the Schedule Performance Index, or SPI, divide earned value by planned value, EV divided by PV. For the Cost Performance Index, CPI, divide earned value by actual cost, EV divided by AC. Just like with our variances, we've got a simple cheat sheet for indices, but this time everything revolves around the number 1 instead of 0. Anything greater than 1? Fantastic news. It means you are ahead of schedule or highly cost efficient. Equals exactly 1? You are perfectly on the money. But if your index drops below 1, your project is struggling. You're either lagging behind schedule or bleeding cash inefficiently.
Section 5,
Let's put all this into action with a real-world example.
We know the formulas now, so let's put on our detective hats and diagnose a project together. Here is our raw data. Take a good look. Our planned value, PV, is $500,000, meaning by today, we plan to have $500,000 worth of work done. Our earned value, EV, is $400,000. So, walking the site, we see we've only actually finished $400,000 worth of work. And our actual cost, AC, is $450,000. We've spent $450,000 out of pocket to get here. Okay, let's run the math. First up, schedule variance. EV minus PV. That's $400,000 minus $500,000, giving us a negative $100,000. Since it's negative, we instantly know we are exactly $100,000 behind schedule in terms of the work we plan to do. Next is cost variance, EV minus AC, $400,000 minus our actual spend of $450,000. That gives us negative $50,000. Again, it's negative. Our diagnosis? The project is currently $50,000 over budget for the work we've actually achieved. Ouch.
Now let's check the indices. Schedule Performance Index, EV divided by PV, 400,000 divided by 500,000. That is 0.80. Since it's less than 1, we know we're moving slowly. Specifically, we're cruising at only 80% of our planned pace.
Finally, our Cost Performance Index, EV divided by AC. 400,000 divided by 450,000, that gives us roughly 0.89, less than 1 again. This literally means that for every single dollar we spent, we're only getting 89 cents of actual earned value back.
So, what's our final verdict as project detectives? Based directly on those math clues we just solved, this project is definitively behind schedule and spending really inefficiently. There's no guessing here, no hoping for the best. The numbers give us total, absolute clarity.
And that brings us to the absolute crucial takeaway here. EVM helps management understand not only how much has been spent, but how much value has actually been achieved. Anybody can look at a spreadsheet and tell you how fast money is leaving the bank. It takes a true professional to measure if the actual delivery on the ground is matching that spend.
Which leaves me with one final question for you as we wrap up this explainer. Are you just tracking the money spent on your projects, or are you actually measuring the true value achieved? Next time you get a big project update, remember those 3 magic letters, PV, EV, and AC. Run the variances, check the indices, and uncover what's really happening behind the curtain. Thanks so much for joining me on this deep dive into EVM, and I'll see you next time.
Earned Value Management, or EVM, helps project managers measure cost and schedule performance by comparing planned work against what's actually done. Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Let's jump right in. Welcome to this explainer. Okay, if you've ever worked on a project, literally any project, you know that feeling, right? That feeling of sheer, absolute panic when someone casually walks up to you and says, "Hey, we just need to make a really small change." Suddenly, you're picturing your perfectly planned timeline completely exploding, your budget going up in flames, and, well, a long string of sleepless nights ahead of you. But you know what? It really doesn't have to be that way. Today, we're demystifying the entire process of project change management. We're going to learn exactly how to take back control of scope, cost, and schedule changes once and for all. Let's do this.
So, here's our game plan for today. We'll kick things off by defining what change management actually is, and then we'll look at why changes occur in the first place. After that, we'll break down the formal change request, walk through the actual change control process, and finally, we'll pit scope creep against controlled change.
All right, Section 1, what is change management? Defining the process. Let's establish our baseline right out of the gate and clear up any misconceptions.
When we talk about project change management, the crucial point is this definition right here. It's the controlled process of evaluating and approving changes to the project. I really want you to focus on that word controlled. It's kind of like a giant funnel. Think about it. If you try to pour a massive bucket of water into a tiny bottle without a funnel, water just goes absolutely everywhere. It's complete chaos, right? But with a funnel, you direct the flow. You see, change itself isn't some wild beast we're trying to slay. It's just new information that needs a structure. We're not just letting changes happen to us. We're evaluating them, running them through our funnel, and then formally making a call to approve or reject them. That sense of control,
That is the absolute secret to keeping literally any project firmly on track. Now, what exactly are we controlling? Well, a project isn't just one isolated thing, is it? It's a complex, living ecosystem. Changes can impact your overall scope, the design, the schedule, your cost, materials, technical specifications, or even your resources, like your team members and equipment. When you realize just how many moving parts exist in a single project, it makes total sense that change is a perfectly natural occurrence across all these variables. And here's the kicker. A shift in one area almost always triggers a ripple effect. Let's say you upgrade your materials from standard wood to custom steel. That doesn't just change the materials column. Nope, it ripples out. It immediately extends your delivery schedule, it inflates your overall costs, and it might even require entirely different contractors to actually do the installation. Everything is connected.
Which brings us directly to Section 2, Why Changes Occur, looking at internal and external factors. And honestly, I want to take a quick second here to normalize the why, and just bust the myth right now that change only happens because someone messed up.
Check out this brilliant breakdown between external and internal factors. On the external side, you've got things like shifting client requirements, brand new regulatory rules, unexpected site conditions, sudden issues with material availability, or updated safety requirements. I mean, imagine you're managing a construction project and bam, you hit solid bedrock while digging the foundation. That's an external site condition you literally couldn't control. Then over on the internal side, sure, you might run into technical problems. But actually on the flip side of that, you might come up with a brilliant design improvement mid-project. Maybe you find a much more efficient software algorithm that adds incredible value for the end user. These are all perfectly normal everyday realities. Change is inevitable, and as you can see, it really isn't always a bad thing.
All right, Section 3, the formal change request, structured docs. So if change is an inevitable reality, how do we handle it without, completely losing our minds? We need a solution. Let's introduce the actual document that kicks off this whole formal control process. Consider this your literal checklist for project survival. The anatomy of a formal change request has to clearly outline the proposed change and the reason for it. But here's where the real magic happens, folks. It must detail the technical impact, the cost impact, the schedule impact, and the risk impact. And I'll tell you, risk impact is absolutely crucial, yet it's so often overlooked. You have to stop and ask, does this change introduce a new safety hazard? Does it create a regulatory hurdle we haven't planned for? By forcing every single proposed change to be broken down into these specific categories, you're doing something incredibly powerful. You're transforming what feels like a scary, chaotic surprise into a highly structured, manageable data point. You strip the emotion right out of it, and you just look purely at the facts. Moving right along to Section 4, the change control process. Assess and act. Now that we have our documentation in hand, it's time to put it to work. We're going to break down this standard 8-step framework into 2 super digestible phases. First, we assess. Then, we act.
So what's really fascinating about the first half of this process is that it is entirely about hitting the pause button. Step 1, the change is identified. Step 2, that change request we were just talking about gets officially submitted. Step 3, we conduct the impact assessment. And Step 4, we do a thorough technical review. Notice what we haven't done yet. We haven't actually changed a single thing. Human nature always screams at us to rush in and just start doing. But this assessment phase, it's all about gathering info, taking a deep breath, and truly understanding the technical reality before taking any rash actions that could totally derail the project. Now, let's see how this builds into the action phase. In Step 5, we do the final cost and schedule evaluation, building right off that technical review we just finished. That financial evaluation leads us directly to Step 6, which is making a formal decision to either approve or reject the change. Only if it gets the green light do we move to Step 7, actually implementing the change into our project. And finally, the big one, Step 8, documentation. Seriously, whatever you do, do not skip Step 8. Documentation is where so many real-world projects fall apart. I mean, think about it. 6 months from now, when the client asks why the budget went over by 10%, having a crystal clear audit trail of approved, documented changes is literally what saved your job. See how methodical that flow is? Financial evaluation, formal decision, deliberate execution, and thorough documentation. Zero panic required.
And that brings us to Section 5, Scope Creep versus Controlled Change, the showdown. This is our final section and honestly, the absolute climax of this explainer today. This is where we put the right way and the disastrously wrong way head to head.
Let's look at these two side by side. Over here on the left, we have scope creep. This is what happens when you just say, yeah, sure, to every little tweak or friendly suggestion without running it through our 8-step process. It's essentially death by 1,000 cuts. It is completely uncontrolled change, and I promise you it almost always leads to a total project breakdown. Timelines stretch out into infinity, budgets magically vanish, and teams just completely burn out because the finish line keeps moving further away. But then, look on the right, we have controlled change. This is what actual professional project management looks like. It uses that formal change control process to maintain firm boundaries, protect the budget, and honestly, keep everyone sane. So you've got frantic, stressful chaos on the left versus a calm, predictable, highly professional methodology on the right. It's really no contest.
Listen, if there is only one thing you remember from our time together today, make it this core truth right here. Change is not necessarily bad. Uncontrolled change is the problem. That is our ultimate key takeaway. We really have to stop viewing change as the mortal enemy of our projects. A brilliant design improvement? That's a great thing. Adapting to a vital safety requirement? Absolutely necessary. The problem is never the change itself. The problem only pops up when we don't have a professional system in place to manage it. So I want to leave you with this provocative question to chew on as you head back to your own workflow today. Is your project actually adapting to change, or is it just falling victim to scope creep? Challenge yourself here. Take these tools we talked about, the formal change requests, that 8-step control process, and apply them to your daily work. Take control of your changes before they take control of you. Thanks so much for joining me for this explainer, and I really hope this structured look at change management sparks your curiosity to master even more project tools down the road.
Project change management is the process of controlling changes. Every change should be assessed for its impact on cost, schedule, scope. Proper change control keeps the project on track.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome back, Focus learners. Okay, today we're unraveling something that, well, let's be honest, it gets a bit of a bad rap. But it is literally the backbone of any successful project, and that is documentation. I know, paperwork isn't exactly the most glamorous part of a project, but we're going to take an organized look at exactly why these essential documents are the true unsung heroes of the whole operation. It's a real game changer once you get it, I promise.
So I want to start off by posing a really simple question to you all. Is a project truly finished when the physical work is done? Think about that for a second. You've poured the concrete, written the code, launched the campaign. It looks done, right? But the core tension of our explainer today is this idea that physical completion might just be a total illusion if you don't have the paper trail to back it up.
Okay, let's dive into this. Here is our roadmap. We're going to cover why documentation actually matters, look at documents across the project lifecycle, talk about mastering document control, and finally, check out modern digital documentation tools.
Section 1. Why documentation actually matters. We really need to completely reframe how we think about this stuff. It's not some boring administrative chore you do just to keep your boss happy, you know? It is the high-stakes, invisible work making everything else you do legitimate. Project documentation provides the ultimate proof for every critical aspect of your project. It captures your decisions and approvals, it details the actual work performed, the costs incurred, and the quality achieved. Just imagine the absolute fallout of a missing record. If you can't prove your costs or verify your testing, an auditor's knock on the door becomes your absolute worst nightmare. You are risking lost money and, frankly, massive liabilities.
So, the crucial point is evidence. All of those aspects we just talked about fundamentally boil down to providing undeniable evidence of reality. Without documentation, it's just your word against someone else's. But with it, you've got a rock-solid factual foundation.
Section 2. Documents across the lifecycle.
Now that we know why this matters, we're going to walk through the chronological arc of a project. Any standard project basically flows through these 5 stages: initiation, planning, execution, control, and closing. As we go through these, I want you to pay attention to how the project's skeleton of documents grows and strengthens right alongside the actual muscle of the physical work.
Step 1 is initiation. This is where it all begins. Before a single wrench is turned, before one line of code is written, you rely on foundational documents to justify the project's very existence. You've got the business case, which basically argues why the project makes sense in the first place, the project charter, which officially authorizes it, and the stakeholder register, identifying exactly who is involved and who actually cares about the outcome.
Once you're authorized, we move right into planning, and this is where the paperwork really balloons to set the rules of engagement. You need a comprehensive project management plan and a scope statement detailing what is, and crucially, what isn't included. You map out timelines with the schedule, your financial limits with the budget, potential pitfalls with the risk register, and your standards with the quality plan. And central to this whole shebang is the WBS.
And this brilliantly illustrates what we call the WBS, which stands for Work Breakdown Structure. It's an acronym you're going to hear constantly because it takes an overwhelming, massive project scope and breaks it down into manageable, bite-sized documents and tasks. It's basically the roadmap for the actual work.
Which brings us to execution. Now, this is where the physical work actually comes to life. And as the work happens, it simultaneously generates a massive, continuous trail of documents. You've got work orders and purchase orders initiating tasks and buying materials. You have inspection reports validating the work, meeting minutes capturing day-to-day decisions, progress reports keeping everyone in the loop, and technical correspondence tracking the daily back and forth. This is the exact paper trail proving that work is actually happening on the ground.
Now look, no project goes perfectly to plan, right? Which is exactly why we have control documents to keep the project on the rails. When things shift in time or money, you need change requests, schedule updates, and cost reports. You have to continuously issue risk updates as new threats inevitably pop up. And, well, when things do not conform to the agreed-upon plan, you generate NCRs, or non-conformance reports, to formally address the issue.
Finally, we reach step 5, closing. Interestingly enough, this is often the most document-heavy phase of all because you are officially handing over the final product. That means providing as-built drawings showing how it was actually constructed, alongside test and commissioning reports proving that it actually works. You hand over training records, warranty docs, operation and maintenance manuals, and spare parts lists. I mean, think about it. It's like trying to return a broken TV without the receipt or the box. Without these manuals and warranties, the client can't actually use the thing. You document the lessons learned for future teams, and most importantly, you secure that final acceptance certificate as your ultimate proof of completion.
Section 3. Mastering document control.
Now, what's really interesting about all these principles is that we've seen the absolute mountain of documents a project creates, moving from chaos to structured order. But creating all those planning and execution documents, it means absolutely nothing if you don't control them properly. You have got to ensure everyone is working from the correct revision and clear approval status. You need strict distribution control and logical document numbering so literally nothing gets lost. You have to understand record retention policies so you know how long to keep the evidence. And then, there is traceability. I really want to focus deeply on traceability here because it is just paramount. It's defined as the ability to track and verify the history and application of a document throughout a project. In a high-stakes environment, it is incredibly vital to have a clear, unbroken historical thread of every single decision, change, and approval. If something goes wrong, even years down the line, traceability is exactly what allows you to look back and understand why a specific choice was made in the first place.
Section 4. Modern digital documentation tools.
Can you imagine managing all this traceability on paper today? It would be an absolute nightmare. Thankfully, the digital shift has completely transformed these massive paper trails into highly streamlined software systems. Let's quickly demystify some of the acronyms that have completely replaced those old metal filing cabinets. First, you have a DMS, a standard document management system, or its more robust cousin, the eDMS, an electronic document management system. For ongoing operations, you might tie into a CMMS, that's a computerized maintenance management system. Really massive organizations will often link their documentation directly into an ERP or enterprise resource planning tool. And of course, almost everything today is largely hosted on cloud platforms and specialized project management software.
Let's move to our conclusion and see how this builds to a real gut punch realization. A project is not completely successful if the physical work is completed, but the required documentation is missing. You can build the most beautiful bridge, you can design the perfect software, or launch an absolutely incredible product, but if the manuals, the warranties, the test reports, and the acceptance certificates aren't in order, well, you have failed to fully complete the project.
So I leave you with this thought to ponder as we wrap up our explainer today. Look at your own work. Is your project actually finished? I challenge you to look at your daily tasks and your physical projects through this undeniable lens of proper documentation, because if you can't prove it, maybe it's not truly done yet. Thanks so much for learning with me today, and I highly encourage you to go organize your own paper trails.
Project documentation is the systematic recording of all information. It includes drawings, specifications, and reports. Approvals and project changes are also recorded. This improves.
Welcome to the Project Management Professional, or PMP, course. In this course, we will learn the essential concepts and practices of professional project management.
Welcome to this explainer. Okay, today we're unpacking something that's absolutely crucial, yet, it's so often misunderstood. We're talking about the final phases of a project, handover and closeout. A lot of folks just assume that once the building is physically built or that shiny new system is installed, the job's entirely done. But honestly, successfully passing that responsibility baton, that is the actual finish line. So here's our roadmap for finishing things the right way. We've got the project handover, meeting handover requirements, tackling the punch list, essential handover documentation, formal project closeout, and finally, learning for next time. All right, part 1, the project handover, or as I like to call it, passing the baton. So what actually is a project handover? Well, it's the formal transfer of the completed work. Now, that could be a facility, a system, or just a piece of equipment, but it's transferring it to the responsible operating organization. You see, a project isn't built in a vacuum, right? It really only succeeds when it's formally handed over to the exact people who are going to manage it day in and day out. Think about the difference between an amateur and a professional here. An amateur, well, they stop when the new power plant equipment just turns on. They hear the hum of the machine and think, awesome, we're done. A professional, though, ensures every single technical requirement is locked in. We're talking securing technical acceptance, finalizing the documentation, comprehensive user training, asset registration, and, of course, a formalized transfer of operational responsibility. It's the whole shebang. Okay, moving on to part 2, meeting handover requirements, which goes way beyond just physical completion. This entire process actually builds progressively through a pretty strict sequence. First, you've got to start with physical completion. Then, you advance through rigorous testing to prove all those individual components actually work. After that, full commissioning ensures the entire system is operating smoothly together. And then comes punch list closure, which is the key that finally lets you secure that formal acceptance approval. But here's the thing, the physical and functional aspects, that's really only half the battle. You absolutely must hand over the practical deliverables too. User training has to be fully completed. Spare parts and specialized tools, those need to be physically delivered. And all your active warranty documents and regulatory certificates must officially change hands. Because, these are the actual tools that empower the operating team for tomorrow. That brings us to part 3, tackling the punch list, which is basically your final bridge to acceptance. Now, a punch list contains outstanding items that simply must be completed before final acceptance. And very often in project management, we treat this as just a pesky, annoying to-do list at the tail end of a massive job. But we really need to reframe how we look at it. The punch list is literally the mandatory final bridge you have to cross. If that list isn't cleared, final acceptance is just impossible, no exceptions. So what's actually on this list? Well, it's usually the critical minutia. Things like minor construction work that slipped through the cracks, missing system labeling, maybe some installation fixes, or necessary documentation corrections. It might even involve localized testing, touch-up painting, or final equipment adjustments. Individually, sure, these seem super minor, but collectively, resolving them is what elevates a project from just mostly done to truly professionally complete. All right, part 4, essential handover documentation. This is your undeniable proof of the finish line. Now, you're going to want to prepare for a literal mountain of paperwork here. Handover documentation ranges from as-built drawings that show what was actually constructed to O&M manuals right down to the final asset register. And you've got to add in test certificates, inspection and commissioning reports, equipment data sheets, spare parts lists, warranty certificates, and training records. I know, it's a ton, but this massive compilation is the absolute proof that your project is ready. Without it, the operations team is just flying blind, for sure. Next up is part 5, formal project closeout, or sealing the deal. So, the keys are handed over, the punch list is done, all the documents are signed, we're done, right? Actually, not quite. We now enter the administrative phase of formal project closeout. This means settling the finances through final cost reconciliation, ensuring contract closure, and getting those final vendor payments out. It also requires properly archiving all project documents so they aren't just lost on some random hard drive, formally releasing your team to their next assignments, and finally filing the official final project report. Which leads us to part
6. Learning for next time, the debrief. The absolute final step of a professional closeout is making sure the organization actually learns from the experience. A truly professional project team simply must pause to ask 3 critical questions in a lessons learned session. And you've got to do this before everyone moves on and just completely forgets what just happened.
Question 1. What went well? We have to honestly evaluate our successes. Like, did a specific vendor just completely over-deliver? Did a new software application speed up our workflow? We absolutely need to document these wins so we understand exactly what strategies we should replicate in the future.
Question 2, and yeah, this is the tough one. What went wrong? We have to look completely objectively at our failures, the unexpected delays, the budget overruns, you name it. The goal here isn't to point fingers or assign blame. It's to map out exactly where our vulnerabilities lie so we can build a fortress against them next time around.
And finally, question 3. What should we do differently next time? We take the honest, raw answers from those first 2 questions and we synthesize those insights. This determines exactly how we're going to adapt and improve our project management processes for the next big initiative. Honestly, this is how organizations actually grow. So, bringing it all back to our power plant example from earlier, I want you to always remember this one rule. Seeing the equipment run is merely an illusion of completion if those operational responsibilities haven't officially transferred over. If the operators don't have the manuals, the training, and the spare parts, the project simply isn't done. Ultimately, a professional closeout is your ultimate guarantee of an asset's future safety and success. Project completion means so much more than finishing construction. It's really about ensuring the organization can safely and effectively operate and maintain that asset for years and years to come. So I want you to take a hard look at your own work processes today and ask yourself, are you truly finishing your projects, or are you just stopping construction? Thanks so much for joining me on this explainer, and I will see you next time.
Project handover and closeout of a successful project. The team completes inspections, clears punch list items, delivers documents, and transfers the facility to operations. Once all